Number 11, we need to find the unit rate, the rate of change, the slope of both functions. So let's check out, this is pounds of apples and the cost. So it's the cost for a pound. This one, the graph, 1 pound of apples costs $2. 2 pounds of apples cost $4. 3 pounds is $6. So I want a unit rate, which is blank, dollars per pound. Okay, so you'll have a number. How many dollars is each pound? Over here on the left one, you're going to get a unit rate for that one as well. How many dollars per pound is it? If you know that 2 apples cost $3, find out what 1 apple would cost. So 2 apples is $3. What would 1 apple? That's pounds. Okay, pounds is X. So you divide by 2, divide by 2. Figure out the unit rate of both of these and tell me which one is more expensive, left one or right one. Number 12, we've got 2 equations. We need to use graphing. To solve this system of equations, we need to find out where do these 2 lines cross each other, and that will be the answer. Well, the first one has a y-intercept of 3, and its slope is up 3 over 1. So we'll start at 1, 2, 3. We're going to go up 3 over 1, up 3 over 1. We'll go the other direction, down and left, because negative and a negative. So we'll go negative 3, negative 1, down 3, left 1, down 3, left 1, down 3, left 1. I think that I got that in the right spots. And then the next one, we're going to start at negative 6, down 6, 1, 2, 3, 4, 5, 6. And we're going to go up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. Maybe you notice something here at this point. These lines are parallel. So like we had on the last video, this is either infinitely many solutions or it's no solutions. So think about, these are 2 lines. Where do they cross? If it's infinite solutions, they're the same line. So what does it mean if they're parallel lines? Number 13, we need to decide, is this positive, negative, none, or linear or nonlinear? If we look at this scatter plot, this is like what we did last week in class. To me, kind of looks like they gave us a line here, but really, if this line wasn't here, I feel like it'd be, I'm not going to be able to erase the line. I don't think this, I think that your book, or not your book, your mountain math people were like trying to trick you. They're like, here's a line of best fit. But really, look at these dots. They're like everywhere, all over the place. That's looking like it's going to be none. And if it's none, that means it's definitely not a line. They're like scattered everywhere. This is not a pattern. Number 14, we need to use the Pythagorean theorem to prove, is this a right triangle? So we have A, B, and C. I know this is C because it's our longest side. We need to plug these numbers into A squared plus B squared equals C squared. We're going to use the converse of the Pythagorean theorem, which means we're going to put it in reverse. If the Pythagorean theorem says if it's a right triangle, then A squared plus B squared does equal C squared. And the converse says if A squared plus B squared is C squared, then it is a right triangle. So plug those numbers in. If these are equal to each other, then it is a right triangle. You're going to say yes, because the Pythagorean theorem works or is true on this triangle.